Hi, third graders. I'm having a little trouble with my camera today. Hoping it will keep working so I can tape the video for you for math today. So we're going to start first with our next math lesson. I'm only going to record one video this week for math. It's a short week. It's only a 4-day week. And we're at the end of this module. So my thought was I would do the one lesson for this, or the one video for the last lesson we have. And then at the end, there is a homework sheet, plus there's a review sheet that I would like you to complete as well. So there's 2 sheets that I will need you to complete at the end of this video. That will help me to see if we're ready to move on to Module 2 next week. And I'm probably going to be assigning some different review stuff through Waggle Math as well to help you continue working on the skills that we've learned through these first 6 lessons in our first module in math. So I'm going to have you go ahead and get your Into Math workbook pages. We're starting with lesson 6, so we're going to be on page 25. I'm going to move my camera over and get it on the book, and then we'll get started. Alrighty, here we go. So I apologize. I gotta move my camera. It might get a little blurry and upside down and all that good stuff. There we go. Looking like it may work now. Sorry about that. Alrighty, so we are lesson 6. Represent multiplication with bar models. I'm going to pull this up a little so we have most of the page on here. And we're starting on page 25. Sorry, I just need to get this ready. Okay. So when we're done this lesson, you are going to be able to use bar models to represent problems about equal groups and to write multiplication equations. And we've been doing a lot with writing multiplication equations, right? We've been using arrays, we've been using, we did the circles with the different groups. Last time we counted using a number line. So we've had lots of different ways that we could show how we can multiply. This is another strategy that you could use to help you multiply, and it is called a bar model. And you can see this picture right here. It kind of looks like a long thin bar, right? And we're going to be using that model to help us multiply. So spark your learning. The cars on the Big Dip roller coaster ride at the museum amusement park are the same size. There are 2 cars. So we have that information right here. Each car has 6 seats. How many seats are on the roller coaster ride? Complete the diagram, then describe how the diagram shows the problem. So when I look at this bar model, I can see that it's one long rectangle and it's broken in half. And when something is broken in half, then I know I have 2 equal pieces. Well, this can represent our 2 cars. This would be 1 car, and this would be the second car. So car 1 and car 2. Each car has 6 seats. So what do you think I should do inside each half of my bar model? I hope you're thinking, or you said out loud, I'm going to put 6 circles or dots or squares, 6 of something in each one. I'm going to just do 6 dots. I just need something that's going to represent my 6 seats in my first car. And then there are 6 seats in my second car. So this tells me, this is going to give me how many total seats I have. How many are all together? Well, if each section is 1 car, and there are 6 seats in each one, that means I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I could say that I have 2 cars multiplied by the 6 seats in each car, and that equals a total of 12 seats. How many seats are on the roller coaster ride? 12. So this is just like when we were doing our arrays or when we were doing our circles. We need to know how many we have, how many are in each, and then we can have a multiplication equation to help us solve for the answer. So each group has 6. There are 2 groups of 6, so there are 12. Okay, moving on to page 26. Now let's build some understanding. The cars on the bumpy tour ride at the fair are the same size. There are 5 cars. Each car has 3 seats. How many seats are on the ride? Complete the bar model to show equal groups. Well, they've started our bar model for us. How many pieces of our bar model did they give us? They gave us 2 pieces. How many total pieces do I need? I need 5 because I need 5 cars. So I'm going to draw 3, 4, and then I need a 5th one. So they're about the same size. I know this one's just a little bit bigger, but they're about the same size. Inside each of these cars, we can see they put 3 dots above. So I've got 1, 2, 3, 1, 2, 3, 1, 2, 3. So that represents the 3 seats in each car. So I'm going to write the number 3 now inside each part of my bar model. So I know I have 1, 2, 3, 4, 5 seats, or 5 boxes, or 5 cars, and there are 3 seats in each one of those cars. So each box in the bar model stands for a group. How many boxes should there be? Well, we just figured that out. There should be 5. If there's 5 cars, that means we need 5 boxes, or 5 pieces of my bar model. How do you know what number to write inside each box? Well, because there are 3 seats in each car, then we know we need to write 3 inside each box. So there are 3 seats in each car. And we knew that each car represents 1 box. Letter C. What part of the bar model represents the total number of seats? Well, that would be this part, this bracket and this label. How many total seats are there? So we're going to say the bracket and label, where it says number of seats. How do we find out how many seats are on the ride? Well, I'm going to count 3 5 times, or I'm going to do 5 times 3. 3, 6, 9, 12, 15. So I know I have 15 seats on the ride. So this bar model tells me I have 5 cars. That's the first number in my multiplication equation. There are 3 seats inside each car. So 5 times 3 equals 15. Alrighty, let's move to page 27. Now we're going to talk about the Zigzag Ride. All kinds of fun rides. It makes me miss amusement parks. We didn't, hard to do those this past summer. Each car in the Zigzag Ride has 4 passengers. There are 3 cars. How many passengers are there? So first we need to show equal groups. So draw boxes to complete the bar model. Write the number of passengers in each car inside each box. Well, we need to figure out how many boxes we need. Well, I know there are 3 cars. And look, they've already given me 1 box with a 4 inside. So I need to do 2 more boxes to complete my bar model. And I know there are 4 passengers that may sit in each one of these cars or boxes. So I'm going to have the number 4 written on each one. That Zoom is really driving me a little crazy. I apologize. I'm going to autofocus that again. Okay. So what multiplication? Oh, we have to put our bracket, right? And we need to know how many. It wants to know, write the number of passengers each side. The question is, how many passengers are there? That's our label, right? When we want to label something, we need to make sure we have that there. So what multiplication equation can we write to model this problem? How many boxes? There are 3. How many are inside each box? The number 4. 3 times 4, we have 4. Plus 4 is 8. Plus 4 is 12. 3 times 4 equals 12. So how many passengers are there? There are 12 passengers. Wish that focus would just stay. All right, let's move on to number 3. A ride at the fair has a train with same-sized cars. There are 4 cars. Each car has 5 seats. How many seats does the train have? Draw a bar model for this problem. My goodness, I'm having a hard time speaking today. So I need how many boxes to complete my bar model? I hope you're thinking, or you said out loud, 4. So I'm going to need 1, 2, 3, 4. Each car has 5 seats. So I'm going to put 5 inside each one. And what am I looking for? I'm looking for how many seats does the train have? Equals seats. What does each box represent? Well, each box represents the number of cars. Right? We had 4 cars and I put 4 boxes. How many boxes should there be? Well, there should be 4 boxes. We just answered that one, didn't we? What number do you write inside each box? Well, we're going to write the number 5. How do you know? Well, because there's 5 seats in each car. There are 5 seats in each car. So how many seats does the train have? Well, I'm going to do, my multiplication problem will be 5 times 4, or we could say 4 times 5. Remember, it's the same one way or the next. 5 times 4, so we've got 5, 10, 15, 20. So I have 20 seats. Nice job. All right, let's practice another one. This one gives us the bar model, and we get to try to figure out what kind of word problem we could solve using this bar model. So Dora drew this bar model. Write a word problem that can be solved using Dora's bar model, and then solve the problem. Well, how many boxes do we have? We have 3 boxes. Inside each box, there is $6. And then we know we need to look for the total amount. What is something that each separate box could represent? If we're talking about money. Maybe she earns $6 babysitting each week. Maybe she saves $6 in her savings account each week. Maybe she puts $6 in her piggy bank each week. Maybe she gave $6 to 3 of her friends, right? So how much money did she give away? I'm going to go with she put $6 in her piggy bank each week. I think that's a cool word problem. So we're going to say that Dora saves $6 in her piggy bank each week. So there's my 6 in each one, right? How much money does she save in, we need what is each square? 1, 2, 3. How much money does she save in 3 weeks? So we could come up with our own word problem for this bar model that was given to us. So if I'm trying to solve this bar model, I know that I have 3 squares. There is $6 in each square. So 3 times 6, if I add 6 plus 6, I have 12. 12 plus 6 equals 18. So to solve the problem, $18 is how much she saves in 3 weeks. So in order to describe what the bar model shows, we know that each box is 1 week. And the $6, that represents the amount of money she saves each week. Sorry. So let's see if we can check for some understanding. See if we know, if we've understood what we've just were learning. The 7 cars on the giant loop ride at the fair are the same size. So we have 7 cars that are the same size. Each car holds 4 people. Write a multiplication equation to model the problem. How many people can the ride hold? So I have 7 cars, right? And each car has 4 people in it. So basically, if I were to write this as a bar model, I would have 1, 2, 3, 4, 5, 6, 7 squares. And in each square, we would have 4 people, right? So 7 times 4. 7 times 4 equals, we have 4, 8, 12, 16, 20, 24, 28. So that means that 28 people can ride the giant loop ride at the fair. Because 7 times 4 equals 28. Number 2. The 5 cars on the cheetah race ride at the fair are the same size. The 5 cars. Each car has 2 riders. How many riders are on the cheetah ride? So we have some steps we need to do to solve. First, we have to draw a bar model. Then we have to write a multiplication equation, and then we have to solve it. Well, let's first draw our bar model. How many squares do I need for this bar model? I am really hoping you were thinking in your head or you said out loud that I need 5 squares because I have 5 cars. And then inside each car, there are 2 riders. So I am trying to figure out how many riders there are. How many total riders there are. Well, what would my multiplication equation be? I have 1, 2, 3, 4, 5 cars multiplied by how many riders are in each side or inside each car? 2. 5 times 2 equals 2, 4, 6, 8, 10. So to solve it, we have 10 riders. All right. I hope you have that all written down. Now remember, when we get to this section where it says on your own, you are welcome to pause the video right here, do it independently, and then come back to the video to check your answers. Or you could just stay right on here with me and do it with me. Whatever is the easiest way for you to do these problems. All righty. On your own, model with mathematics. Javon has 4 boxes of granola bars like this one. How many granola bars are there in the 4 boxes? Now, they didn't tell me how many are in each box. How am I going to find that information? I hope my very observant 3rd graders were able to see that there are 6 granola bars inside each box. If we looked at the picture it gave us, the label it gave us. Sometimes we have to look in other areas to help us solve our problem. So we know we have 4 of these boxes, and we know that there are 6 granola bars in each box. So let's first draw our bar model. I need how many boxes? I hope you said 6. Oh, I'm sorry. I was thinking of the granola bars. Just kidding. Oh my goodness. Sorry about that. We need 4 boxes. I apologize. I hope you all just screamed at your video and said, Mrs. Blair-Wilcox, what are you doing? See, this is what happens when I try to do something when I'm a little bit distracted. I apologize. I will try to be more fully present. Okay, regroup, rewind. We have 4 boxes because there are 4 boxes of granola bars. And inside each box there are 6 granola bars. Phew. Sorry about that big mistake. I apologize. I hope you were all way ahead of me and already had 4 boxes and then you didn't make the same mistake I did. And we know that this is telling us how many granola bars there are altogether. We want to know how many altogether. So our multiplication equation would be, we have 4 boxes multiplied by how many granola bars in each box? 6. So that equals, I have 6 plus 6 is 12, plus 6 is 18, plus 6 is 24. So I have 24 granola bars. Good job. And again, I apologize. I was getting ahead of myself. Alrighty, number 4. Satya uses a bar model to show 9 packages with 3 shirts in each package. Owen counts on a number line to show the same information. Explain how using a number line to count is like using a bar model. Well, remember when we used the number line, we skip counted, right? We counted up. We would have, for this one, counted up by 3s 9 times. And in a bar model, we would draw 9 boxes with 3 shirts in each line. So I'm going to show this in picture form, okay? So I would have 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? And inside each one, I would have 3 shirts. And this would give me the total number of shirts. If I were to use a or a number line, I would start at 0. I'm going to say, let's go up to 30. So we're going to do, in the middle would be 15. We're going to do 1, 2, 3, 4, 5, 6, 7, 8, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. And if we were to do this, we would count, we would go up 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And we have to do this how many times? We need to do this 9 times. We've already done it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we would have, sorry, I gotta squeeze those in. So we would have 27 total here if we counted, right, in groups of 3 9 times. Groups of 3 9 times. 9 times 3 equals 27 shirts. So I showed it in picture form. You could also describe it using words. You could just say using a number line to count and using this bar model to count are alike because they each show that you are combining equal groups. So either way works. I'm okay if you don't write all this out because this is just your practice sheet. Anyway, I really only need to be able to see your homework sheet, but I do want to show you how the 2 of them look, and if you wrote it in words, it could be that using both of them are alike because you're combining equal groups. Okay? All right, Jackson drew this bar model. We are going to write our own word problem that can be solved using the bar model. So I'm looking at 4 groups, 4 equal groups. Inside each group is 9. What could I use for this problem? Could I continue the fair model and say there's a ride that has 4 cars of the same size and each car holds 9 people? How many total people can be on the ride? Sure could. Could I say inside each classroom 9 students can be in each classroom? And how many total students would be in 4 classrooms? Could I say we bought 4 packages of hot dogs? Inside each package of hot dogs there are 9 hot dogs. How many hot dogs did we buy? Right? See, all kinds of things that you could use to solve this problem. I think I'm going to use the hot dog one. That one seems easy enough. So, there are 4 packages of hot dogs. Each package has 9 hot dogs. How many hot dogs are in the 4 packages? And I can solve this by multiplying, right? I have 4 packages. Inside each package are 9 hot dogs. Excuse me. So if I were to multiply 4 times 9, 9, 18, 27, 36. So there are 36 hot dogs. But remember, you could do anything as long as you're talking about 4 equal groups with 9 in each group. And our last page, page 30. Each bicycle has 2 wheels. There are 6 bicycles in the bicycle rack. How many wheels are on the 6 bicycles? Well, we first want to draw a bar model to show the problem. I have 6 bicycles, so I need 6 boxes. How many wheels are on each bicycle? There are 2 wheels on each bicycle. And we know we are looking for the total number of wheels, right? How many wheels? How did we know how many boxes to draw? Because there were 6 bicycles, right? How did we know what number to write inside each box? There are 2 wheels on each bicycle. So how many wheels are on the 6 bicycles? Well, I know that I have 6 bicycles multiplied by 2 wheels on each one. 6 times 2 equals 12. So we have 12 wheels. our last problem. Bryce Canyon National Park in Utah has a 3-mile-long trail called the Navajo Trail. Junie hikes the trail each day for 3 days. How many miles does Junie hike? Well, let's think about that. There are 3 days that she's hiking, and each day she hikes 3 miles. So each day would be its own box. Inside each box would be a 3 because it's 3 miles. And we're looking for the total number of miles. So I have 3 boxes multiplied by 3 miles equals 3 times 3 is 3, 6, 9. So that's 9 miles. So she walks or hikes 9 miles total after 3 days. All right, so your homework first will be lesson 1.6, and then I also want you to complete the review 1, so the front and the back. You can always look back on these pages to help you if you're concerned or confused. These first 4 are using vocabulary. We have vocabulary words here, and you're going to put 1 vocabulary word for each line. You're going to answer the questions. So I want this page sent back to school or taken a picture of the front and the back and sent to me, and the homework for 1.6. And that's all for math, other than your regular programs that you need to do each day. Sum Dog, Waggle Math, and Reflex for your math for this week. I hope you all enjoyed your 3-day weekend. I hope you enjoy these next 4 days, and I will be back next week to do some more videos. Remember, we will have our meeting on Wednesday at 3:15. Whoever would like to meet with me can meet with me. I know for sure Emma will probably be on Wednesday at 3:15, and we will do some practice, and I will answer any questions that you may have. All right, have a great day. Bye.